So we're going to look at one variable inequalities and two variable inequalities and make sure we understand the difference between them. So one variable inequality, one way to remember it is the solution is a one-dimensional solution. Okay, it's also solutions on a number line. Now we can use a graph to still help us understand this one variable inequality. Okay, so I'm going to factor this because zeros are always going to be important. So x plus 5, or hold on here, it's going to be x plus 6, x minus 2 is greater than or equal to 0. Okay, so what that means is I have zeros at -6 and +2. Okay, and it's a parabola that basically goes through like that. Okay, now a one variable inequality means we really just want to know where this graph is above 0. Okay, so really we just want to take that point where it's equal to 0, and where it's above 0, it's going to be here and here. Okay, because it's greater than or equal to 0. So on a number line, we just show it on the solution on a number line. We have 6, we include 6. All the numbers on this side are part of the solution. So if I plug any numbers on that part of the number line, so like -7, okay, we're going to have -7 times -9, or sorry, -1 times -9 is going to give us positive, so it's bigger than or equal to 0. And then from 2 and bigger, same thing's going to happen. We're going to have numbers bigger than 0 because we're going to end up with positive times positive, which is bigger than 0. Okay, so one variable inequality, we can use the graph to see where the graph is above or below the x-axis. Okay, because a 0, I'm just going to highlight this. I'll use a highlighter here. This 0 means the 0 on this axis here. Okay, so the boundary are going to be the zeros. Now this is contrasting with the two variable inequality. Okay, so this is the exact same equation, but now it's a two variable inequality. Okay, so I'm going to write this as y is greater than or equal to. Still going to factor it because I want to know what this graph looks like. So plus 6 x minus 2. So same graph, I'm going to have at 6 and 2. Okay, and then I'm going to actually need my vertex because since this is a two variable inequality, the solution is two-dimensional. So it's going to be area. Okay, so it's not on a number line, it's actually the area on the graph. So when I graph the vertex here, the vertex is going to be, looks like from -6, the average is going to be -2. Okay, so the middle is going to be at -2. I should move that over a little bit closer. Okay, so the vertex is going to be at -2. I plug -2 in. I'm going to end up with, looks like -8, -20, plus, so it's going to be -16. So -16, let's just say -16 is down here. So there's my parabola. And the solution boundary actually now is the graph. Okay, it's that actual line. So it's greater than or equal to means we're going to include that line. So we're going to draw that line in solid. So that is a boundary line. Okay, so this represents the two-dimensional boundary line. And so my inequality is that I want above that graph. Okay, so that means that I'm going to have this area here as my solution. So all the coordinates in that solution, in that area, are going to solve this inequality. So for example, 0, 0, if I put 0 in for here, 0 in for there, okay, and I'm going to show my test coordinate. So I'm going to test. 0, 0 always is a good coordinate to test. Okay, when I substitute that in, I get 0 is greater than or equal to +6 times -2, which is negative, which is definitely smaller than 0. So 0 is definitely bigger than -12. So that point here, my test point, is pretty good. Okay, it works. So that must be that region above the line. So two-variable inequality is going to be, the solution is going to be a two-dimensional solution. So it's going to be the area in this graph. Okay, and the boundary becomes the line, the actual line of the graph, where here the boundaries are my zeros. Okay, so here the boundary is represented by this line here, and we're talking about above or below that line.